Hey! So now we are going to go on to day 3 of circles. What? Y'all aren't excited? Let's go. We're going circles. You know, like a dog chasing its tail in a circle. Anyways. Okay, so last day of circles, we're going to look at segment relationships. So we did it in general. Then we looked at angles. Now we're going to look at segments. Okay, so today, like I said, we're going to look at segments formed that by words hard. We're going to find the lengths of segments formed by lines that intersect the circles. They may intersect in the middle. They may intersect on the outside. We'll see what happens. So this theorem that we're going to start with describes the relationship among 4 segments that are formed when 2 chords intersect in the interior of the circle. So if 2 chords intersect in the interior of the circle, then the product, what does product mean? Product means to multiply. Of the lengths of the segments of the chords are equal. So if 2 segments cross each other in the circle, then the product of the lengths of those segments are equal to each other. So in this picture here, A times B equals X times Y. That B sounds really country. A times B. Anyways, I don't know what's gotten into me, but we'll keep going. So A times B, this diagonal going from A to B, A times B equals X times Y. Okay, so that's simple enough. Let's look at an example. Keeping the same idea. You multiply what's on the diagonal together and set it equal to what's on the other diagonal. So 8 times X equals 6 times 5. It's going to be 8X equals 30. If we divide by 8, we get X equals, we can write it as a fraction, as 15 over 4, or we could turn that into a decimal and say it's 3.75. On those, that's it. You're just multiplying. That is it. Let's look at another. Let's keep this train rolling. Archaeologists discovered a fragment of an ancient disc. To calculate its original diameter, they draw the chord AB. So they draw this chord right here. And its perpendicular bisector PQ. Find the disc diameter. Okay, so we have to find PR. PR is our diameter. That's our goal. This is the diameter. Okay, so it's a perpendicular bisector. What does bisector mean? It means it cuts it in half. So A to Q is 5. That means B to Q is also 5. P to Q, it tells us is 3. We don't know what Q to R is. So we have to find that first. Fair enough. 3 times X equals 5 times 5. 3 times X, well, that's just 3X. 5 times 5 is 25. We divide by 3, we get x equals 25 over 3. Now, are we done? No, we're not. This is just that piece from R to Q. They want us to find the whole diameter. So we have to take this 25 over 3 and add it to the 3 that's already there. So 3 plus 25 over 3. Now, if you put it in your calculator just like this, it'll tell you that that is 34 over 3 inches. And that's right. If you want to leave it like that, go for it. You do you, boo-boo. However, let's think of this as like we're the archaeologists and somebody's giving us a report saying, hey, I've analyzed this fragment. I think it's this diameter. Do you want them coming to you and saying, I've analyzed this fragment. The diameter is 34 over 3 inches. And be like, what? 34 over 3, that's the exact answer. Great. So that's how many inches? So if I round this to, let's say 2 decimal places, that would be 11.33 inches. So 11 1/3 inches, basically. Now somebody comes to you and says, hey, the disc is 11 1/3 inches, or 11.33 inches. Oh, okay, so I'm looking for a disc that's about a foot in diameter. Got it. You move on. So either answer works. But anyways, sometimes we just got to keep it real. Keep it real. So that's when 2 chords intersect. Now we have a secant segment. A secant segment is a segment of a secant with at least one endpoint on the circle. An exterior secant segment is a secant segment that lies in the exterior of the circle with one endpoint on the circle. Now, without a picture, you may be thinking, what the heck are we even talking about, buddy? So let's look at one. Well, let's go to the next page. Boom, there we are. So the secant product theorem, what it's saying is a secant goes through the circle. So like this line right here, this orange line, that is a secant segment. One's outside the circle, it goes in, and the other one ends on the circle. So that's a secant segment. Now, there's a theorem that goes with that. The whole times the outside of one segment is equal to the whole times the outside of the other. So the whole A times just the outside. So A times B is equal to the whole, which is X, times Y on the other. That's the secant product theorem. So what do we need? We need the whole, and then we need the outside. So let's look at this example. Now, I see they give me each piece. That's great. I'm going to need the whole. All the way from R to T is what? 4 plus 6 is 10. All the way from R to Q, 5 plus X. So now when we find X, we do the whole. So I'm going to do the one with the X in it, the whole. 5 plus X times the outside. The outside of that one is just 5. So 5 plus x times 5 equals the whole of the other. 10 times just the outside, 4. So 5 plus x times 5 equals 10 times 4. Let's distribute our 5. So 5 times 5 gives us 25. 5 times x gives us 5x. So 25 plus 5x equals 10 times 4, which is 40. Move the 25 over. We have 5x equals 15. Divide by 5, and we get x equals 3. Are we done? Find the value of x. Yes, we're done. X equals 3. And the last one. A tangent segment. Is a segment of a tangent with one endpoint on the circle. AB and AC are tangent segments. So if this segment were to keep going, it would just touch that circle at B. That's what makes it a tangent segment. If it were to keep going, if it were a full line, it would just touch that circle at one point and then keep going. Remember back 2 days ago, we said a tangent, wow, words hard. A tangent is like when you're little. Like if this is your sibling right here, I'm not touching you, I'm not touching you, I'm not touching you. Oops, I touched you. And then you run away because they're about to, why'd you touch me? I said don't touch me. That's tangent. I'm not touching you, I'm not touching you, I touched you. And I'm going to start running the other way now. So we said on that same first day that AB is congruent to AC. We said that. Not that you can tell that's a congruence. Come on. Not that you can tell that's a congruent symbol, but there we go. That looks horrendous. Hang on. Take 2. Not much better, but anyways. So now we're going to have the secant tangent product theorem, meaning the tangent is going to touch just the outside. The secant's going to just bust its way through the whole circle. Move out the way. Okay, that theorem says if we take the whole tangent, not the whole tangent, the whole secant. So this piece on this side is talking about the secant. The whole secant times the outside is equal to the tangent squared. So A times B equals x squared. Let's look at this last example. Our secant is the long one. So what's the whole thing? The whole thing is 9. So we're going to have the whole 9 times the outside 4 equals the tangent x squared. 9 times 4 is 36. And then how do I get rid of a square? Take the square root. So 6 equals x. That means x is equal to 6. There we have it. So we had 3 theorems. We have the chords where you just multiply, so equal. We have the two secants. Whole times outside equals whole times outside. And then we have the secant tangent. Whole times outside equals tangent squared. Those are our three relationships that we're going to talk about today. So I think I went through this a little fast. If you need to rewind, watch it again, watch my corniness again, go for it. But if not, then stay tuned and we'll be on to the guided practice.